Hey y'all, Miss Stewart here. We are factoring linear expressions today. Okay, in order to factor linear expressions, we need to find the GCF or the greatest common factor. That is the number, the largest number that goes into both terms or both numbers that we are looking at. So the first one we're going to take a look at are these monomials. That means numbers with specific terms. Okay, so 5x and 15x, all right, they both have x, so we know that's going to be part of our common factor. Okay, and the number 5 goes into both 5 and 15. Since 5 is the largest factor of 5, we know that is the greatest common factor. So 5x will get factored out, and then we have a little distributive property sort of situation going on here with what's left in both of these terms. So if these were being added to one another and we factor out 5x, that means I would have 1 plus 3 because 15 divided by 5 is 3. Okay, so that's what it would look like if we are factoring that out. So 5x is the GCF there. Okay. And again, since they both have the same variables, the variable is part of what is being factored out. Okay. Now 21 and 35, okay, they are 7 goes into both of these. So 7 times 3 is 21, 7 times 5 is 35. So 7m is my GCF or my greatest common factor. Okay. This one says we're again using, we're finding GCF. It says use prime factorization, but we're just factoring out. Okay. So the numbers that go into both 16 and 24, uh, since 16 doesn't go into 24 evenly, 8 goes into both of those. All right. And since they both have both of the same variables, X and Y will both be factored out of them. Okay, so 8xy is our greatest common factor between these two numbers. Okay, now take a look down here on number 8, 25 and 65. Okay, uh, 25 does not go into 65 evenly. Um, and 5 is another factor of 25 that goes into both of them. So 5. And then this has X, Y, and Z, but this one only has X and Y. So only X and Y become your greatest common factor. The Z would remain inside that parenthesis there, okay, with the other two leftover terms or numbers, okay? So let's take a look at what this looks like in an expression, the way we were just talking about as far as distributive property. Okay, so 3x minus 12, they do not both have the same variable, so the variable will not get factored out on this. All right, 3 does go into negative 12 evenly or 12 evenly, so 3 is that GCF. 3x divided by 3 just leaves you with x, and negative 12 divided by 3 is negative 4. So your new expression with the 3 factored out or the GCF factored out would be 3 and then parentheses x minus 4. Okay, let's take a look at another one similar right below it, 13x plus 28. Okay, 13 is a prime number. No other number goes into that. So it says if it cannot be factored, right, cannot be factored. So since 1 and 13 are its only factors and 1 doesn't need to be pulled out, it would remain the same. We would say cannot be factored. All right, now here with our fraction, all right, don't freak out, it's just a fraction, but look, the coefficient and the constant are exactly the same. Okay, so that is your common factor. So we're going to factor out 2/5. Okay, and again, x does not occur on both, so x will remain inside. And then when you divide 2/5 divided by 2/5, you are left with 1. So minus 1 will go inside your parentheses there. Okay, 14 is similar to one we looked at earlier, where 18 and 9, we've got the x and y, but the 9 only has x. Okay, so 9 goes into both of those, so that will be factored out. The x is on both, so that will be factored out. And when we do our division by 9x, 18x divided by 9x gives us 2y. Okay, 2x, y, x, those cancel out and are 1. And then 9x divided by 9x is 1. So that is what is left. Okay, and we're going to look at one more slightly complicated problem right down here. My coefficient to both of these is 3/8, so 3/8 gets factored out. And x and z are the factors that are the same here. So x and z will both be factored out. We will be left with only the y on this one, and then 3/8 xz divided by 3/8 xz is just 1. Okay, so that will be what is left inside your parentheses. Okay, there are several more that you can try similar to these throughout. Please feel free to give those a shot.